Hello everyone, I am Abhijit Lal, Assistant Professor, Department of EEE, Bhilai Institute of Technology, Durg. Today we are going to study about filter circuit. So, this will be the contents for today's lecture. We will discuss about the introduction of filter circuit, why it is necessary and what are the filter circuits. Then we will discuss in details the different types of filters. Now, what is filter circuit and why it is required? The rectifier converts the alternating current into direct current. The obtained direct current at the output is not a pure DC current, or we can say that direct current, it is a pulsating DC current. So, the pulsating DC is not constant, it fluctuates with respect to time. When this fluctuating DC is applied to any electronic device, the device may not work properly. So, as we have seen in the rectifier circuit, the output obtained is not pure DC, there are some ripples which makes it a fluctuating DC. So, what filter does is converts that fluctuating DC into pure DC. Sometimes the device may also be damaged, so the fluctuating DC is not useful in most of the applications. Therefore, we need a direct current that does not fluctuate with respect to time. So, the only solution for this is smoothing the fluctuating DC. So, this smoothing process is done by a device called filter. So, the filter is required after a rectification process to make the fluctuating DC to convert into a flat, or we can say that pure DC. Now, what are the filter circuits? A filter circuit is an electronic device which blocks the AC component present in the rectified output and allows the DC component to reach the load. So, as we have seen in the output of different type of rectifiers, the output DC contains some part of AC that was called as ripple. So, what filter circuit do is it blocks the AC component present in the rectified output and allows only the DC component to reach the load side. So, in this way, at the load for which we require a DC supply, a pure DC is obtained. So, the following figure shows the functionality of a filter circuit. So, the given figure shows the input side where the rectified output which contains ripples is given to the filter circuit, and at the output of the filter circuit we obtain a pure DC, or the output shown here is for a ideal filter, although it is not a purely flat line, but the ripple contents are reduced. So, we can say that the output obtained from the filter circuit are more smoothened than the rectified output. So, the ripples are removed from that. A filter circuit is constructed using two main components, inductor and capacitor. So, the two components placed in the filter circuits are the inductor and capacitor. So, the removal of the ripple and the smoothing of the wave is done by these two components. So, an inductor allows DC and blocks AC, whereas a capacitor allows AC and blocks DC. So, the functioning of both the inductor and capacitor are totally opposite. Inductor only allows DC to pass through it, whereas it blocks the AC current, whereas the DC is blocked by the capacitor, but capacitor allows AC to flow through it. So, this concept is used in the filter circuit. A filter circuit consists of passive circuit elements, that is inductors, capacitors, resistors and their combination. The filter action depends upon the electrical properties of passive circuit elements. For example, an inductor allows the DC to pass through it, but it blocks AC. On the other hand, a capacitor allows the AC to pass through it, but it blocks the DC. Now, let us study about different types of filter. Now, this different types of filters are categorized depending upon the components used for the filtering process. So, the different types of filters are inductor filter, capacitor filter, T filter, LC filter, and last is CLC or pi filter. Now, let us see the first type of filter, which is inductor filter. So, So, this type of filter is called a choke filter. It consists of an inductor L which is inserted between the rectifier and the load resistance RL. So, the picture shows the load side having the resistance RL. Before the load, an inductor is connected in series. So, the output from the rectifier is passed through the inductor and then that is given to the load. So, an inductor is connected in series and it forms a inductor filter, or it is also called as choke filter. So, the rectifier contains AC components as well as DC components. So, that AC components is removed by this filter circuit. When the output passes through the inductor, it offers a high resistance to the AC component and 0 resistance to the DC component. Therefore, AC components of the rectified output are blocked and only DC components are raised at the load. So, inductor filters, also known as inductor input filters or simply LC filters, or we can say that L filters, are electronic circuits used to filter and smooth electrical signals. So, what inductor filter do here is that it blocks the AC components because it offers a very high resistance to the AC component and 0 resistance to the DC component. So, at the load side we get a pure DC, or we can say that practically the DC contains less ripples compared to the rectified output. So, inductor filters are also known as inductor input filters or L filters, and they are the electronic circuits used to filter and smooth electrical signals. They consist of inductor L connected in series with the load. Now, let us discuss some advantages of inductor filter. The first advantage of using inductor filter is noise reduction. Inductor filters are effective at reducing high frequency noise and electromagnetic interference from electrical signals. They are often used in power supplies to eliminate or reduce voltage spikes and ripple. Second application is improved signal quality. By removing high frequency noise and spikes, the inductor filters can help improve the overall quality and stability of electrical signals, making them suitable for sensitive applications. So, the inductor filter reduce the high frequency noise, and due to that the signal quality is increased. So, this is the main advantage of inductor filter. Next advantage is the energy storage. The inductors store energy in their magnetic fields, which can be beneficial in certain applications. They can act as energy reservoirs, providing additional power during brief periods of high demand. Next advantage is its simple design. The basic design of an inductor filter is relatively simple, consisting of only passive elements like inductor. This simplicity makes them cost effective and easy to implement. Now, let us discuss some disadvantages of inductor filter. The first disadvantage is its size and weight. So, inductors tend to be physically larger and heavier than other passive components such as resistors and capacitors. So, this can be a drawback in compact or lightweight electronic devices. So, the main disadvantage is its size or shape. If we compare the inductor with resistor or capacitor, its size is large and it is heavier. So, for a very compact electronic circuit or devices, the inductors are omitted and other filters or other component circuits are used for certain applications. Next disadvantage or limitation is limited frequency range. The inductor filters are most effective at filtering high frequency noise, but their effectiveness decreases at very low or very high frequency or very low frequencies. Choosing the right inductor or the capacitor values is crucial to target specific frequency ranges. Third disadvantage is energy loss. Inductors have resistance and can dissipate some energy as heat. This can result in energy loss in the filter, which may be a concern in energy efficient applications. Next disadvantage is complex calculations. Designing inductor filters can be more complex than designing simple passive filters. Calculating the appropriate values for the inductor to achieve the desired filtering effect can require expertise. Next disadvantage is its limited voltage ratings. Inductors have voltage ratings, and exceeding these ratings can lead to saturation or damage. Care must be taken when designing and using inductor filters to ensure they can handle the voltage levels present in the circuit. Now, let us discuss the second type of filter, which is called as capacitor filter. So, in this filter, a capacitor is connected across the load. So, during the rise of the voltage cycle, it gets charged, and this charge is supplied to the load during the fall in the voltage cycle. So, this process is repeated for each cycle, and thus the ripple is reduced across the load. So, the following picture shows the circuit of capacitor filter, in which RL is the load resistance, and the output of the rectifier is shown here as pulsating DC, which is input to the filter. The capacitor is connected parallel to the load. So, what capacitor does is that when the voltage rises, the capacitor gets charged, and when the voltage decreases, the capacitor discharges its value, so that at the output from the figure we can see the ripples are reduced. So, in this way the ripples or the fluctuating elements are reduced using the capacitor filter. So, it is popular because of its low cost, small size, less weight and good characteristics. The capacitor filters are useful for loading up to 50 milliampere as in transistor radio battery eliminators. Capacitor filters are also known as capacitor input filters or simply RC filters, and they are the electronic circuits used to filter and smooth electrical signals. They consist of a capacitor C and a resistor R connected in series or parallel. Now, let us discuss the advantages of capacitor filter. The first advantage is the high pass filtering. So, capacitor filters are effective at blocking low frequency signals while allowing high frequency signals to pass through it. They are commonly used to eliminate ripple and provide DC voltage in power supply applications. Next advantage is compact and lightweight. The capacitors are typically smaller and lighter than inductors, making them suitable for applications where space and weight constants are critical. Next advantage is its low cost. Capacitors are relatively inexpensive and readily available, which makes them a cost effective choice for filtering applications. Next advantage is its simple design. The basic design of a capacitor filter is straightforward with only two passive components, that is a capacitor and a resistor. So, this simplicity facilitates easy integration into electronic circuits. Now, let us discuss some disadvantages of capacitor filter. So, first disadvantage is voltage drop. In capacitor filters, the output voltage can experience a gradual decrease over time due to the discharge of the capacitor. This can be a limitation in applications requiring a constant voltage output. Next disadvantage is limited filtering range. So, a capacitor filters are most effective at filtering low frequency noise and ripple. So, they are less effective at attenuating very high frequency noise. Additional filtering stages may be required for comprehensive noise suppression. Next disadvantage is energy storage. Unlike inductors, capacitors do not store energy. This means that they cannot provide additional power during brief periods of high demand, which could be a drawback in certain applications. Next disadvantage is its voltage rating. Capacitors have voltage ratings, and exceeding these ratings can lead to capacitor failure, which may result in circuit damage or safety hazards. So, proper selection of capacitors with suitable voltage ratings is essential. Next disadvantage is complex ripple reduction. So, achieving a specific level of ripple reduction may occur careful selection of resistor and capacitor values. designing precise capacitor filters can be more complex than it initially appears. Now, let us discuss the third type of filter, which is T filter. A T filter, also known as a T section filter or T type filter, is a passive electronic filter configuration that consists of three components arranged in the shape of the letter T. That is why its name is called as T filter. So, these components typically include two series connected resistors and a capacitor connected between them. So, the T filters are primarily used for high pass or low pass filtering applications depending on how they are configured. So, the following figure shows the circuit for T filter. In this, the three elements are connected in the fashion of T. So, that is why it is called as T filter. So, the components present in T filter are: a T filter consists of two resistors R1 and R2, or in place of resistors we can also use inductors, that is they can be denoted by L1 and L2 connected in series, and a capacitor C connected between the junction of the resistors or inductors and ground, forming the shape of a T. So, the filter type is, the type of filter is high pass or low pass, which depends on the arrangement of the components. So, in a high pass T filter, the input signal is applied at one end of the resistor chain, that is R1, and the filtered output is taken across the capacitor C, whereas in a low pass T filter, the input signal is applied across the capacitor C and the filtered output is taken at the junction of the resistors R2 or conductor, or we can say that inductor L2. So, in this T filter, either the resistors are used or the inductors are used. Now, let us discuss the characteristics of this T filters. First, let us discuss about the frequency response. The frequency response of a T filter is determined by the values of the resistors and the capacitors, or the value of inductor. So, high pass T filters allow high frequency signals to pass through while attenuating low frequency signals, and low pass T filters allow low frequency signals to pass through while attenuating high frequency signals. Next is filter scope. Next is filter slope. The slope of the filter's response, that is the rate of attenuation, depends on the values of the resistor or inductor and the capacitor. So, steeper slopes can be achieved with appropriate component values. Now, let us discuss the advantages of T filters. The first advantage is simplicity. The T filters have a straightforward design with only three passive components, making them cost effective and easy to implement. Next advantage is customizable response. By choosing specific resistor or inductor and capacitor values, we can tailor the filter to meet the required frequency response. Next advantage is its versatility. T filters can be used for both high pass and low pass filtering, offering the various range for different applications. Now, let us discuss the disadvantages of T filter. First disadvantage is limited bandwidth. T filters have a limited bandwidth, meaning they are optimized for a specific range of frequencies. Achieving wideband filtering may require more complex filter designs. Next disadvantage is energy loss. So, the resistors in T filters introduce energy losses in the form of heat, which can be a concern in applications requiring high efficiency. The third disadvantage is the component value. Precisely designing a T filter for a specific cut of frequencies may require careful selection of resistor or inductor and capacitor values. So, component tolerances can affect filter performances. So, the summary of T filters can be explained as: the T filters are passive electronic filter configurations used for high pass or low pass filtering. They offer simplicity, customization and versatility, but have limitations in terms of bandwidth and energy losses. The choice of a T filter or any filter type depends on the specific filtering requirements and constraints of the application. Now, let us discuss the fourth type of filter, which is called as LC filter. In the inductor filter, the ripple factor is directly proportional to the load resistance. On the other hand, in a capacitor filter, it varies inversely with the load resistance. Hence, if we combine the inductor filter with the capacitor, the ripple factor will become almost independent of the load filter. It is also known as inductor input filter, choke input filter, L input or LC section. The figure shows the circuit for LC filter. So, in this circuit, we can see the inductor is connected in series with the load, whereas capacitor is connected across the load, and RL is the load resistance. So, the output of the rectifier is given to the filter, and the filter removes the ripples from the output, and a pure DC is obtained at the output of filter. So, in this circuit, a choke is connected in series with the load. It offers a high resistance to the AC components and allows the DC component to flow through the load. The capacitor across the load is connected in parallel, which filters out any AC component flowing through the choke. So, in this way, the ripples are rectified and a smooth DC is provided through the load. Now, let us discuss some advantages of LC filter. The first advantage is effective filtering. The LC filters are highly effective at filtering and shaping electrical signals, allowing you to selectively pass desired frequencies while attenuating unwanted ones. This is crucial in applications where signal quality is essential. Next advantage is low power dissipation. LC filters are passive components, meaning they do not consume power themselves. This is beneficial for applications where power efficiency is a concern. Next advantage is a simple design. They have a relatively simple design consisting of just two passive components, an inductor and a capacitor. So, this simplicity makes them cost effective and easy to implement in various circuits. Next advantage is energy storage. Inductors in LC filters can store energy in their magnetic fields, which can be useful in applications requiring energy buffering or transient response improvement. Next advantage is versatility. LC filters can be configured as high pass, low pass, band pass or band stop filters, making them versatile for a wide range of filtering needs. Now, let us discuss the disadvantages of LC filters. The first disadvantage is component sizing. Properly selecting the values of the inductor and capacitor to achieve the desired filtering effect can be challenging, especially for complex filtering requirements. So, designing precise LC filters can be a complex job. Next disadvantage is limited bandwidth. LC filters have limited bandwidth and may not effectively filter signals with frequencies far from the cutoff frequency. They are best suited for applications within a specific frequency range. Next disadvantage is losses. Both the inductor and capacitor can introduce some losses into the circuit, including resistive losses in the inductor and dielectric losses in the capacitor. So, this can affect overall circuit efficiency. Next disadvantage is the size and weight. Inductors can be relatively large and heavy, which can be a limitation in compact or portable electronic devices. Smaller form factor components may be preferred in such cases. The last disadvantage is complexity for multi-stage filters. So, in applications requiring multi-stages of filtering, managing the interaction between stages and achieving the desired overall response can be complex. It may be require careful design and analysis. So, LC filters are valuable components in electronics for their effective frequency selective filtering capabilities. They are commonly used to remove noise and shape signal waveforms. However, their design and component selection can be challenging, and they have limitations such as limited bandwidth and potential losses. The choice to use an LC filter should align with the specific filtering requirements and constants of the circuit. Now, let us discuss the last type of filter, which is called as CLC filter or pi filter. So, it consists of one inductor and two capacitors connected across each end. So, the CLC filter, its name is derived from capacitor, inductor, capacitor. So, one form of CLC filter can consist of two capacitor and an inductor. Form can be the two capacitor with a resistor, which forms a pi shape, and from there the name derived as pi filter. So, the three components are arranged in the shape of the Greek letter pi, and from which the name is derived as the pi filter. So, it is also called as the capacitor input pi filter. So, the figure shows the circuit for the CLC or pi filter, in which the two capacitors are connected in parallel or across the load RL, the load resistance RL, and inductor is connected in series with it. The input capacitor C1 is selected to offer very low reactance to the ripple frequency, hence major parts of filtering are done by C1. Most of the remaining ripples are removed by the combination action of L and C2. So, this circuit gives a much better filter than the LC filter. However, C1 is still directly connected across the supply and would need a high pulse of current if the load current is large. So, this filter is used for low current equipment. So, the CLC or pi filters are common types of passive electronic filters used for various applications. Now, let us discuss the advantages of CLC filter. So, this advantage is particularly for the capacitor, inductor, capacitor filter. So, this CLC filter is having the effective filtering. So, CLC filters provide effective filtering by combining the advantages of both inductive and capacitive elements. They can offer good attenuation of both high and low frequencies. Next advantage is low power dissipation. Like other passive filters, CLC filters do not consume power themselves, which can be advantageous for power efficient applications. Next advantage is simple design. They have a relatively simple design consisting of three passive components, an inductor and two capacitors. So, this simplicity makes them cost effective and easy to integrate. Now, let us discuss the disadvantages of CLC filter. First disadvantage is component sizing. Selecting the appropriate values for the inductor and capacitors can be challenging, especially for complex filtering requirements. So, precise design may require careful considerations. Next disadvantage is size and weight. So, inductors which are part of CLC filters can be relatively large and heavy, which can be a limitation in compact or portable electronic devices. Next disadvantage is complexity for multi-stage filters. So, when multiple stages of filtering are required, managing the interaction between stages and achieving the desired overall responses can be a complex task. Now, let us discuss the advantages of pi filter. So, the first advantage is effective high pass or low pass filtering. So, pi filters can be configured as either high pass or low pass filters and are particularly effective at one of these tasks. They offer good attenuation in their chosen pass band. Next advantage is its simple design. Like CLC filters, pi filters have a relatively simple design consisting of three passive components, that is two resistors and a capacitor, or two capacitor and a resistor. So, here we can see a pi filter consists of three component, which can be either two resistor and a capacitor or two capacitor and a resistor which makes a very simple design for the filter circuit. Now, let us discuss the disadvantages of pi filter, which consist of resistor and capacitor. So, the first disadvantage is limited bandwidth. So, the pi filters are optimized for either high pass or low pass operation, which means they are less versatile compared to CLC filters in terms of filtering frequency ranges. Next disadvantage is energy loss. The resistors in pi filters introduce energy losses in the form of heat, which can be a concern in applications requiring high efficiency. The next disadvantage is component values. Precisely designing a pi filter for a specific cutoff frequencies may require careful selection of resistor and capacitor values. So, the choice between CLC and pi filter depends on the specific filtering requirements of a given application. So, the pi filter is also called as CLC filter when the components used are the capacitor and inductor, and it is simply called as pi filter when the components used are resistor and the capacitor. So, depending upon the requirement of the application, the pi filters are designed and the components are selected according to that. CLC filters offer more versatility in terms of filtering different frequency ranges, but may have larger components. So, pi filters are effective in their chosen passband, but have limited bandwidth and introduce energy losses through resistors. So, careful design and component selection are crucial for both types of filters to achieve the desired filtering characteristics. So, in today's lecture we have discussed about different types of filters and the components used for the circuits to make the filter and to remove the ripples from the rectified output and get a ripple free DC output. So, these are the filter circuits which are always used with the rectifiers to obtain a ripple free output. Thank you.